Welcome to Precision Agriculture in the Southeast. This program is funded by a grant from the Alabama soybean producers and the Alabama wheat and feed grain producers. With me today is Dr. John Fulton. He's our Precision Ag guy. John, you've done great things with our Precision Ag program. Today we want to talk about variable rate technology. Variable rate. I understand that. Technology a little bit, but different amounts for different areas and small areas. Tell us about variable rate technology for agriculture.
Well, this is one of the areas that our Alabama farmers are really starting to capture some benefits. We saw a lot of interest kind of in the 90s, early 2000s, and kind of plateaued. But more recently, we're seeing a lot more adoption of variable rate for various inputs. So going back to considering that input stewardship, which is just a must today in these businesses. The farm operation has to use inputs efficiently, and this is the real technology that enables that to occur, whether it's seed, fertilizer, lime, and some of these other inputs. So anyways, talking about variable rate today, Mark, and just simply put, it's trying to base your application of inputs on some kind of field or crop variability that we either measure or understand out there, and then only applying what's needed back to that crop or soil. And the big thing, and we promote in all this, at the end of the day, when we start to break fields into either zones or grids, we know that we're going to be able to more accurately deliver inputs for the crops that we grow on our farm. So variable rate application, or VRA, is a term that a lot of people use, or it's really the technology, or variable rate technology is the second level. We've got to have the technology in order to implement the VRA program that we choose. Here's just some quick things. A lot of people, when they hear variable rate, they think very quickly to fertilizers, basically granular fertilizers for P and K and nitrogen in a sense. But lime has been one area that our farmers have really capitalized and seen a profitable benefit to doing variable rate application. So that's one. More recently, a lot of talk, as you know, around variable rate seeding with seed costs, but also planters today coming from the dealer with hydraulic drives as shown in the bottom right. All of a sudden the question is how really can I take advantage of that drive considering my seed costs, and can I do a better job of adjusting populations based on some kind of variability that we measure or know out there in the field. So that's kind of two quick examples that a lot of farmers of fertilizer, lime, and seeding have been really the pioneers in Alabama for variable rate application. The concept itself, implies that you're going to vary some type of input. Typically, we're going to think about that as a rate or a population for planters. We really want to understand the spatial variability out there, and then ultimately the two things, Mark, that we got to drive down to, and these are not easy questions to answer, is what's that knowledge? Where am I going to put what and how much? And that's probably the huge question that most guys are going to really have to face and work through, and that's something a lot of times we have to learn over several years in terms of really kind of fine-tuning our variable rate application program at the farm level. The method really comes down to the technology. That's what we're going to talk a little bit about today, and just give a little insight about how you do it, but really what technology do I need in place to implement this and enable me to build that variable rate application program.
John, this would be one advantage of working the same fields year after year, because if you go to a new field, you won't know. It'll take you a while to build the data points to know how to vary the rates.
And understanding the history of that field, as we know over the last 30 or 40 years, we've gone from some fields that were somewhat smaller, tore down those fences, and all of a sudden knowing that history just in itself brings in that idea of doing some variable rate based on management history. But the biggest thing that we talk about from a variable rate, that knowledge, there's no replacement for that farmer knowledge. And that's the number one data layer, in our opinion, that really needs to be implemented or discussed about what do you know about that field, or what makes sense to do in that field. Capturing that data is very critical and to be successful in these programs. With that, again, going back to what we've shown prior, that again, we're looking at a field that's irrigated, but you can see some areas where there might be some differences in water holding capacity in this particular field. But from a variable rate perspective, I mean, we can go across the board, Mark, and talk about any input today. One of the more recent hot topics is variable rate irrigation.
Yeah.
Really, how can we capitalize with some of the potential constraints on water usage and some of the legal aspects ongoing between states? We want to be smart in how we use our water, but in a sense, fertilizer really starts to make sense. In some cases, nitrogen in particular on some crops like corn can be profitable. Lime, no doubt about it, we got to have our pH in the right range, and going out and a lot of times we'll find hot spots or cold spots, and just getting the pH right.
Look at that picture in your slide, John. That cries out for variable rate nitrogen right there.
Yeah.
Some of it's saying I've got plenty, and some of it's saying give me some more.
Absolutely, and that is a cornfield, so that's a very good observation. That it seems to make that might be what makes most sense for me on that field. So, anyways, kind of moving forward, and this again going back, and these are just examples. We like to see a lot of data layers, or a few data layers that, especially those yield maps. You can see where we're on the left, blue's high and red's low, and so you can definitely see there's some differences in yield in that particular field. If we can build a history of that over time, we can see a fertility map there where we got some really high P and K. Actually, if I'd shown you both. Fertility levels. So why don't we don't want to be applying that out there? To implement that, I can come up with a prescription rate. In this case, just as an example, this is just a pH. Again, you can see there was some areas that really need to be addressed in pH, and helping some areas get back up to that production level that we expect. So there's a quick payback for that. So just some ideas here. We got to have some data in hand. Typically, we like to see yield maps. We probably go out and implement some soil sampling strategies, grid or zone, taking that and turning that around into a prescription map. And that's where it gets a little sticky, is who's going to make that map for you, that prescription map? Is that something you're going to do in-house as a farmer? Or are you going to reach out and work with someone, whether that's a input supplier or some kind of data, third-party data manager that would help me generate those prescription maps. So anyways, talking about the actual technology, this is a very simple representation. Typically, we're going to have a display there in the cab. That's going to be our interface. Also, that's where we're going to stick those prescription maps and record data in the cab. We're going to, of course, have a DGPS receiver. We recommend, we talked about GPS versus DGPS, but we want something that has the best, as good as accuracy as we can. We can get away with WAS a lot of times when we talk about fertilizer. The metering device, and that's going to vary by the implement or applicator itself. And then we're going to have either a hydraulic motor drive or electric drives are becoming very popular. That's going to vary the rate. In this case, we're looking at a traditional spinner spreader fertilizer lime applicator. It's an apron chain that's basically the speed of that chain is going to drive what the actual application rate will be. So we load our map in the top left. We got our GPS. We know where we're at any point in that field, and we're going to apply what that map says in this case. And the hydraulic motor is going to do all the control aspects, or the speed of that chain. Just a simplified kind of flow chart here. Again, we have to have some kind of actuator. We have to have a computer and some kind of controller or variable rate controller that sits in there saying, hey, we need to apply 57 pounds per acre, for example. That actuator will adjust the product to that rate, and on the backside we get a controlled application of 57 pounds per acre. We have some kind of feedback loop that tells us what the actual rate is or speed of that chain. When it's calibrated, it says, yes, I'm putting out 57. That's what the computer's telling me. And so we're assuring that we're getting very accurately that application rate put out. So that's just kind of the overview of how this works. The question is what's out there for actuators, you know, and what kind of computers or controllers, and we'll try and go through some of that here. From an approach perspective, Mark, you know, you can do manual adjustments. You can take some of these displays and very simply just either with a knob or most of these touchscreens, I can just move the rate up and down myself. You know, that's an ability for me to just look at, do I get a response on my farm? You know, and so I don't have to go to all this buying a receiver and buying the ability or trying to figure out the ability to generate maps, the prescription maps. Maybe I just do some simple manual adjustments out there in the field and just, do I get a response for my operation? That's just a very good kind of entry level, simple.
I mean, you would know where the low spots were from history and do it that way.
Absolutely. And I've heard, you know, we've had some farmers that, especially on the planting side, just go in the field and we either make strips or we adjust based on that, and we just use yield monitors just to see if we get some kind of response. If we get some kind of response, we're probably going to look into this even deeper and probably make a full investment in a suite of technology for our operation. And so that moves us either into the map-based or sensor-based. We're not going to talk much about the sensor-based today, but the map-based is the most popular here in Alabama. But essentially, you're generating that prescription map as we showed prior. We take that, load it into either the tractor, spreader, whatever that might be, and based on our position in the field, it's going to put that rate out at that location. Sensor-based, which we're really excited in the program. We see a lot of potential in the future. We still have a little bit of growth to do, but it makes sense for nitrogen and some of the grain crops, small grains in particular. But essentially what we're doing is sensing that crop real time and adjusting the application of nitrogen in this example based on what that crop is telling us. Trimble's Green Seeker would be a good example. Topcom's Crop Spec, those are commercially available sensor systems out there. There's others that are definitely available. Those two are probably the most prevalent here in the Southeast for our farmers or input suppliers to use and provide that service back to the farmers. Sensors, again, we think they're the real future because if we can adjust rates in season. And so a lot of times when you're doing a map base, you build those maps prior to the season or early in the growing season and go out and apply. Crop sensors will give us a look real time at that crop based on where we're at a growth stage and apply just hopefully what we need.
Well, like we were talking about earlier, a lot you can tell by seeing and automated where the density of the green, how green is it? Well, that would affect whether you were putting out insecticide or fungicide or nitrogen or a lot of issues that you could tell with a color reading.
Absolutely.
And that's just, wow, who would have thought that just a little bit back? This is cutting edge stuff, it seems to me.
Yeah, and I think we're just kind of see that basically the sensors grow. I mean, we're starting to see some interest in that, and it's exciting because that really drives down to kind of the essence of what we think about when we consider site-specific management. So going back, we're going to focus, again, a lot of rate controllers. This is just an example of one. I can be going across that field and again just turn the knob and adjust the rate right on the go. Okay, and again, I don't need the GPS. I don't need much. Yeah. It's just, hey, can I look and see if there's a response? I can do strips. I could be, low, kind of nominal rate, high rate, and do some strips and just look at my yield map. If they stand out, then probably want to look better, a little closer into my variable rate program. Again, here's the prescription map, and the question is, how do you develop this? This is a grid-based map, 1 acre grid-based map. 2.5 acre grids are generally what most people would consider potentially profitable, but you could do zone-based. Ultimately, we believe zone-based is where most people will go to, but coming up with these maps can be very complex because do I own the land? Do I rent the land? What knowledge do I have? Do I got yield data? And what's bringing that soil data and some other things in? I mean, it's just not a cookie cutter or silver bullet approach in all this. So a lot of things go into how we come up with these maps.
And once again, if you have a history, if the same person's been working the land for a long time, he knows where the zones are. And it's easier for him to go in there and test for whatever and go with that than it would be. And I think about John, have you ever worked with those maps that they developed in the 1930s, soil maps? And man, that data is almost 100 years old now, but it shows those zones through fields. And it's been my experience, you go in there and test and do 1 acre test, boy, it conforms to that 100-year-old data.
Yeah, I mean the soil map data and that's freely accessible today is a place to start with, no doubt about it. But most of the guys will find very quickly that they're going to adjust that. So they might go out and kind of use the soil maps, maybe yield maps to kind of get started. But in years 2, 3, and 4, they'll note that I find out as I build that knowledge base, I need to really change those zones even more. So, or the grids, I start combining grids, or hey, this grid, there seems to be something going on based on the yield map. I need to go out there and do some very strategic ground truthing, whether that's soil or crop related, to figure out what's going on.
And once again, like you've said, this is not just fertility. This is insect control. I mean, you get an insect problem, it's not field wide, it's zoned.
Absolutely.
And disease pressure is not yield field wide, it's in a zone.
Absolutely. Absolutely. So we just list out the steps here on kind of the general approach. This isn't absolute, but it kind of gives an overview. How do I develop those grids and zones? They got to make sense for your operation is what we want to emphasize. There isn't one thing. What works for you, Mark, might not work for me. Then you got to figure out what rate that I want to apply in each zone, whatever input that might be. And then you got to, from there, generate this prescription map. You either have to have the software in-house or get someone to help. The big thing, the two key things is make sure your units are correct, pounds per acre, seeds per acre, whatever that might be. It's very important that what's generated in the map matches up with the technology I'm using on the equipment, because if it doesn't, you might get a little surprise. The other thing is make sure that when I export that data file or that prescription map from the farm software, it's exported for my display specific. So if I'm using the John Deere 2630 behind me, most of these softwares would have a suite, say John Deere. You can give the display. So when you take it and bring that thumb drive out to the tractor or sprayer or whatever that might be, that it works for that particular piece of equipment. So those are two important things: the units and the fact that that prescription map is built for the very particular display that's in that equipment. You upload that. You need to configure your equipment. That includes configuring where your GPS is relative to the point of application. Most of these displays, like the 2630 behind us, do a very good job. There's a little setup. Hey, I'm planting. Where's my GPS receiver relative to the planter unit? They'll usually give graphical representations in there. You can get your tape measure out. But getting that all set up is very critical that you have success out in the field. You need to calibrate. We'll talk just a little bit about that, but that's important. We're really emphasizing it's not just variable rate that really helps improve my stewardship, but it's being able to really dial in rates very accurately, and that's really what a lot of this technology gives. It's always a surprise that we never realized where we were based on. And then you can go out to the field and implement. Just some examples today, Mark, just giving everyone, we'll start with planters. you know, we think back to the days with the manual drives. You got these basically a transmission that sits at the center of the planter. You got to go out and adjust that transmission based on the crop and what's your desired target rate. You normally will get out the operator's manual and they'll have tables that says, hey, this rate, you need to be in this gear transmission based on the seat plate or meter that you got. Very difficult to correctly set, and it's very difficult to calibrate. You know, I can't back in my shop and calibrate that planter in a lot of cases. We take that transmission out, we put a hydraulic drive. Here's an example of a Trimble Rawson drive. Basically, it was a Rawson drive that Trimble's purchased. But you take all those chains out, you put this hydraulic motor, and you got more of a fine-tuned adjustment. It's just not right. So that's all we're doing. We're taking that mechanical drive that has a bunch of gears, throwing the hydraulic drive in. You got to have the display. Typically, what we call electrical control unit will sit between this, just a box that has your wiring harness plugged into, and that electronic control unit communicates between the display and a hydraulic motor to drive what the exact rate that you want to put out. Here's a litter spreader, but this could also be a fertilizer. Essentially, we take and put a hydraulic control valve on. There's several out there on the market. We also have to add a feedback mechanism. Basically, in that lower left picture is a Dickey John encoder that just tells us what the speed of that apron chain is turning. With a little bit of calibration, knowing the density of the product, we can very accurately meter product. So if I want to put 1 ton, 2 tons, or 3 tons, knowing and doing some calibration based on the speed, I know how much exactly I'm putting out. But the important thing is, again, you notice that hydraulic drive. Basically, in a lot of cases, these litter or some of the fertilizer, smaller, will come with a manually set. But again, you manually set it and it doesn't have any flow compensation. So as I put more a heavier material or lighter material or anything like that, it doesn't compensate. I essentially put electric operated valve, in this case what we call a pulse width modulated valve. You see a little solenoid on there, and that basically will control the rate applied automatically no matter what my, based on the feedback of that encoder. So we're just swapping out an older valve, about a several $100 swap out, as long as I got the display and, again, an electrical control unit that can communicate with that pulse width modulated valve. I'm in the business of being able to go out and adjust rates on the go. Here's all the things, and people can study, but the display, the receiver, you see the electrical ECU, that essentially, again, is the connection between the display and the valve itself, and also reading in what that feedback mechanism, in this case a coder, so we know at any point in time very accurately how much we're putting out, and we control that based on the map or just from the screen. Finally, we'll talk a little bit about a nitrogen side dress unit, very popular because nitrogen, especially in corn, starts to make sense that you could see some benefits to that. Here's the John Blue piston pump. You've probably seen this, Mark, a lot of times. It's basically wheel-driven or ground-driven pump. We take that. We really can't do variable rate with that because as we speed up, it puts the same rate out and things. But essentially, I take that wheel-driven device off, and I put a hydraulic motor that drives that pump directly. Add the ECU, and in the cab I got a display, and all of a sudden I can really easily fine-tune my nitrogen rate on that side dress unit. There are some sprayers out there this very same setup could be used on. So again, just kind of giving an idea of some of the components. Today, a lot of times in some of the cases, especially on planters, we're starting to see electric motors essentially, and not hydraulics. So with that, just a few things. Everything, variable rate gives you a lot of capacity to really fine-tune your input management programs, fertility, things like that. But there are some things to consider. We're going to just talk about one in particular, and then talk about rate control in terms of how long it takes. But the first thing is, let's just make sure that we're checking that applicator. This is a variable rate nitrogen side dress unit. You can see that there was some issues just based on the picture and the streaking that occurred. But that setup and just checking and getting off and checking that every nozzles, you don't have any plugs, things like that on a row is very important, or this is going to happen to you. So we really encourage people, because of the ability, you can really calibrate these systems. You do it in a stationary position. You get into the display and say, I want to do a calibration. If I say I'm trying to drop, 30,000 seeds per acre, it'll drive. You can do a quick weigh and knowing the number of seeds, the weight. You can very quickly get your planter really fine-tuned into that target rate. Same with the nitrogen applicator. And then in the bottom right, we always encourage people to really fine-tune their fertilizer spreaders. We can basically weigh that material coming off the apron chain to make sure that what the computer thinks it's doing is actually, and we can get that down to 2 to 1% or less error, which is really where we want to be, not 5 or 10% that we'll get a lot of times with some of these manual-driven systems. So with that, the last thing I'll say about that is not everything happens instantaneously, but there's a benefit in most of these systems to set what we call a look-ahead time. We just shift to make sure that rate change occurs. So again, a look-ahead time is a value. Typically in most of these will be somewhere on the order to half second to 3 seconds, depending on the implements. And most of your dealers or equipment companies can really help you know what that value should be. The final thing I'll say is the fact that all this technology gives us the ability to collect data, post, and look at that. Just a quick, we can actually verify what we did out in the field. It's a good record-keeping device. I think as we move forward, Mark, and some of the regulations and things, these will be necessity in order to kind of that verification. Someone does audit you, but it basically can tell you when, where, how much, and ultimately in some cases you could build some research within that field that you could come back and use the yield maps to see what kind of response you got. So a lot of power in this type of data if used properly. We're starting to see a lot more of this used as a means to do some on-farm testing, but you got to know what you put out there in order to make sure that what you're measuring is what you think you're measuring. So with that, we talked a lot about components of variable rate applications, specifically to the technology. We didn't get into the zones and grids. We'll do that in another lesson, but the idea here is the technology can really advance, and the idea of really fine-tuning and getting your target rates right, whether that's population on a planter or pounds per acre that you're putting out with your spreaders, we can really do that much more accurately with this technology, and that's probably the biggest benefit it provides, the ability to calibrate and ensure you're within 1 or 2% of what your target is out there. So with that, hopefully we've kind of covered variable rate technology in a broad sense.
John, you've done planter clinics and sprayer clinics, and I didn't put the two and two together till now that your planter and sprayer, it's got to be actually doing what it's saying it's doing. It's got to be putting out the seeds or the ounces, and the ground speed. It's got to be exactly what it's telling you to achieve all these things. And I know that having your planter work right is a big deal, but I didn't realize that on this variable, it's absolutely necessary.
Yeah, and it's, anytime I look at, we'll call it a rate controller, what's put on that screen, you want to make sure you calibrate to ensure that is proper. You can get in situations very quickly where it says you're putting out this rate, but in reality, because you didn't calibrate or check something, we've seen 10, 15, 20% off, and that's not where we want to be.
Well, and the other thing you just touched on, but legal, not our legal, but producers' legal. If you've got a map, if you've got documentation, this is hard documentation. It's not my word versus your word. It's my maps, my documentation versus your yeah. And that's going to be a good thing.
Absolutely. If I can show that someone comes and says, well, you were out in that field last week and I saw a little bit of drift, or, you know, some of the guys applying litter, there's always scrutiny around
Yes.
that from the neighbors. But if I can show when did it, I did it in the proper way, and it was all within legal bounds, you know, that's a much more powerful tool. Now, how much value that is, well, no one maybe will ever ask you, but if someone does ask you, and you know,
And you've
ultimately,
got that.
it's
And it'll keep it from going too far down the road. If you've got documentation and they've got just saying,
that's right.
well, no lawyer's going to take that case.
That's right.
They don't want that. Thank you, John. Appreciate your help. We'll have more on precision agriculture in the Southeast. Please tune in.